So I'll be explaining how to determine what property table to use in a typical Thermodynamics 1 problem. So first of all, to be able to determine that, you have to understand how a substance behaves when it's changing phase from liquid to gaseous. So it's not as simple as it may seem. So one key thing to understand is that when you heat up a substance, it either makes the temperature increase in the system, or it actually makes it undergo a phase change, at which point the temperature does not increase until it's done changing phase. So here we have a temperature diagram. So we have the y-axis, we have the temperature on the y-axis, and you can either have specific volume, internal energy, enthalpy, or entropy on the x-axis. So at the start, when you're heating up the substance, the temperature is going to increase. That's pretty intuitive, right? So you can see that here the lines increase. So you heat up the system, temperature increases. At a certain point, the substance is going to reach this line here, which is the saturated liquid line. So at that point, it's still entirely liquid, but it has reached the saturated temperature. From this point onwards, for a while at least, the temperature is not going to increase, but the substance will be changing phase. So it's going to enter the mixture area, which is this whole area here under the bell curve. So it's going to slowly but surely become more and more gaseous until it reaches this line, which is the saturated vapor line. At that point, it has completely finished changing phase, but it is still at the saturated temperature until you continue heating it up, at which point it's going to start increasing temperature again. And it's going to enter the superheated vapor area, which is this area here. So what does this all mean in practice? So I've put some points here. So we have different points that are pretty important for problems that you're going to want to look out for. And basically you have three tables. You have one table for each shaded area. So we have the compressed liquid table, the mixture tables, which you have the temperature and the pressure tables. So if you have information on temperature, you're going to use the temperature tables. If you have information on pressure, you're going to use the pressure tables. So here it's a temperature diagram, right? So we're kind of assuming to use temperature tables for mixture at least. That is not the case for the other two tables. So compressed liquid, and here it's the superheated vapor table. So for both compressed liquid and superheated, it's pretty simple. It becomes a bit more complicated for the mixture, and most of the problems are going to be the mixture. But let's start at the beginning. So compressed liquid. You might be tempted to use only the compressed liquid tables, but you actually have to check for one condition, which is specific to the compressed liquid area. So we have the first point here and the second point here. So they're on different lines, right? These different lines represent different pressures. So this line is at a constant pressure, this one constant pressure, and so on. So the first point here, as we can see, if you follow the line, is going to be higher than 5 MPa, which is what I wrote. And this second line here is lower than 5 MPa, megapascal. So this is not to scale. That's not really the focus here, but the point is higher or lower than 5 MPa. So if it is higher, you can use, and you have to use the compressed liquid table. If, however, it is lower than 5 MPa, the behavior of the substance is actually not really adequate if you look at the compressed liquid tables. So you're going to have to use the mixture tables, but not any mixture table. You actually have to use the temperature table because the assumption does not work on the pressure table. So basically you would just assume your temperature to be, or pressure to be, like the saturated pressure or temperature. So to be this pressure here. So that is when the pressure is lower than 5 megapascals. After that point, so once you get on the saturated liquid line, it is still entirely liquid, but theoretically it marks the beginning of the phase change. So it's from this point onwards, from this point to the saturated vapor point. So this point marks the beginning of the mixture, and this point or this line marks the end of the mixture. So anywhere from this line to this line and in between, you're always going to use the mixture tables. So let's say point 2, you're going to use the mixture table, point 3, 3.1, 3.2, and 4 mixture tables. But there are things to note. So for example, if you're at point 2, you have what's called the quality, which basically measures the amount of gas you have in the mixture. So here the quality would be 0 because it's still entirely liquid. When you get in the mixture, quality is going to increase slowly until it gets to the saturated vapor line, which is going to have a quality of 1. So you can think of it as a percentage of vapor. So you have 0% vapor and 100% vapor. So that is one thing to note. Another thing to note is that your x-axis, so either specific volume, as I said, or these other ones here, you're going to mark them with, they're usually going to be marked with a subscript F when you're on the saturated liquid line, and a subscript G on the saturated vapor line. So that marks basically the minimum and maximum of this. If you're anywhere in between, you're going to be in between those two values. So yes, one thing to note here, as you can see, there's the critical point. So I've not explained that. The critical point is a point at which the quality is basically undefined, because your substance goes from liquid to vapor instantly. So there's, at that single point, actually, liquid and vapor coexists. So the quality does not really make sense. That point or any point above it, that applies. But we're usually not going to have any like problems in this area. So if you're below the critical point, it actually does not matter. It does not change anything to your procedure, what table you're gonna use. It's really just the same as any other point in the mixture table. So there's nothing really important here to point out. And finally, so once you're gone from the saturated vapor line, you're going to be superheated vapor. So you just use the superheated vapor table, simple as that. It does not matter here whether you're at 5 MPa, less than 5 MPa, or more than 5 MPa. In both cases, you use the superheated vapor. And yeah, that's it. Thank you.